Yeah. Can we invoke the method on null? Yeah.
Sir,
Yeah.
sir, might be in the format method of the string class, we are passing hello world as an argument and returning something, so it will not give any error.
But can we invoke method on null? That's the question. Question is S1 is set to null, and then we are saying, okay, let's call the format method.
Yes, sir, but from the any object we can call the method of the string class.
Can we call that? Okay, we can call method of the string class. Is it? Okay, let's check this. Let me go to JShell, and yeah, which method you would like to call? Let me know. String class methods. Okay. Okay. Let's see the. So we have string s1 equals null. Okay, and you would like to call s1 dot length. Will it work? We can call method on string. Yeah, s1 dot format, and yeah, you want to pass parameter to a method. You want to use a method which uses a parameter. It's a null pointer exception. Yeah, but if I'm using the method format, and if I'm saying, okay, it's not giving an error. What's the reason? See, the other two methods of string, they are giving null pointer exception, but this one format method doesn't give a null pointer exception. Yeah. So what's the reason? Okay. Look at this code, right? Okay. What is format? It's a method, but what kind of method is it? Okay. Format, sorry. Format is a static method. Okay. See, if there is a static method, we normally what we should be doing, we should be using the class name, and it should have been something like string dot format that I should have been doing, right? Okay, and this is what is actually what should have been done, string dot format. But even if you write s1 dot format, okay, fine, during the compilation part, okay, the compiler finds out that, oh, we don't have such an instance method, right? You're calling on an instance, but it finds out that there's no such a there's no instance method called format for, and which can be invoked on the object of s1. Okay, so what it would do, oh, it finds out, oh, this is a static method, and therefore right at compile time itself, though you had written this, the compiler had actually replaced it with a class name. So, uh, when it compiles, and if you are using a static method for an object, okay, it will see, oh, this object is of which type? Oh, it's of type string. Okay, that means it should be a string dot format. So you may have written this, right? But it would change. It would have changed to this. So it doesn't matter what is S1. Clear? So your S1 dot format became string dot format during compilation. Yeah, clear. Okay. Fine. So fine. So any questions? Yeah, any questions from yesterday's thing? Anyone has questions? Yeah. Or we proceed?
Yes, sir.
Okay.
Sir.
Yeah.
Sir, it is implicitly converting our object name with the class name.
Yes.
So it will apply in all static methods or only for specific this format.
Anywhere you have a static method, right? Static method normally you should use class name, right? Okay. But if you don't use class
Yes,
name
sir.
and if you use the object, okay, then the compiler will automatically replace with the class name. Okay, so it's not related to the object. Invoking static method does not involve an object. Fine, format is a static method.
Yes, sir.
And does not use the object of string. Fine, you pass a string as parameter, but it's not on a string object. Okay, fine.
Okay, sir.
Yeah. So normally we have this. Oh, if we have a null, we'll get a null pointer exception. But of course, static methods, they are not related to object. So anyway, I would advise, actually, when you write your code, don't do the second form. Okay, don't do this form, s1.format. Don't use it that way. Always use class name. Static method, always use class name. Though it may seem, oh, it works with objects. No, it's not working with object. The compiler is making the correction. Okay, fine. Yeah, any other questions? Yeah. So this is one thing. Yeah, any other questions? Anyone has a question? Okay, so yesterday I think we saw about the functional interface, lambda expression. Any question there? Some of the exercises were there. Yeah. You did the exercise? Tried, at least attempted the exercise?
Yes, sir.
Okay. So,
yes, sir.
So any questions there? Things are working or you had some problems? Some of the things could be done, something could not be done.
Yes, sir. We're facing some problem
Okay.
in that.
So yeah, go ahead. What is the problem?
Sir, we applied the functional interface and trying to
so in the current yeah.
Yes, sir.
Okay. So here I think the part was that we don't want penalty to be a fixed thing, so we don't want to use this one, right? And rather we were introducing one as an instance variable, or you would like to keep it static. What have you tried? Yeah. Yeah.
So there were two issues actually.
Yeah.
The transaction log was not updating in the output, and the second thing that we were confused that we want to create a set penalty method in the current account, right?
Yeah.
So what to done with the penalty, because the penalty was an interface. So how could we create a class, or whether we need to create a class for it or an interface for it? That was a confusion.
Okay. So penalty is a functional interface. I think it has been mentioned that it is a functional interface.
Yes, sir.
Okay.
But it has been used in the below example as a class. That's where the confusion was.
Where is it used as a class? I didn't get.
In the set penalty method, it is mentioned as an argument that the object of penalty class is passing.
So object of penalty class means object of anything class. Is it mentioned as class and penalty? Object of penalty. Is the word class used there?
No, sir. It only shows the word penalty.
Yeah. So penalty is a function interface. Yes, the object of penalty. Is lambda expression not an object?
Yes, sir. It
We
is.
saw yesterday, right? It's an object of the function. The penalty is a function now. Okay, fine. I'll do one thing. I'll keep it static, and we'll do that, right? Okay, and let's. Okay, so we'll not do it on every instance of current account, but you want, you can. Okay, we'll not keep it final, so we don't, so that we can have the setter method. It will be a static method in that case, and so this is what was expected, and it won't be 100. Okay, but here would be a lambda expression. Okay, fine. Here we should have a lambda expression. That's one thing. Clear? And when I was talking of a setter method, what was needed was public static method. Okay, and we say set penalty, where parameter is a penalty. Okay, and this is quite simple. Yeah, set penalty is this method, but then it needs to be used. Okay, from the test account. Okay, we'll use it from the test account and check it out. Fine. So this is one change. Now another one was okay. Let me update the current account here itself. Okay. Now since we are having penalty as a functional interface, and I've mentioned that the method in that functional interface would be called compute, which takes two parameters. Yeah. Okay. So it's new transaction, and oh, this penalty. Yeah. This penalty will be replaced with the. Okay, so it is penalty dot compute, isn't it? It's now a computed value. In compute, there are two parameters. I think first one is what? Minimum balance or balance?
Minimum balance.
Okay, so let's use the minimum balance. And second one is this dot get
Balance.
balance. And just use the get balance method. Okay, so balance won't be directly available. We'll have to use the get balance as a method. Okay, so what I have done here is I have only put the changes in the current account, but we still have to define the functional interface called penalty. Okay, right? Penalty is a functional interface, and then this should work, right? Currently, penalty is not defined. Yeah, and this is an functional interface, and to still define that. Okay, but the required changes I have made in the current account. Right? But clear, what is the change we are looking at? Okay, so penalty is a functional interface. So when I say set penalty, it's a simple thing. Setter methods are just take a value and assign, right? Replace. Okay, fine. Let's create the penalty as a functional interface now. Okay, so we'll keep it as package bank. Okay, and you can also use the annotation at the rate functional interface. And let's have a public interface called penalty. And what do we keep in penalty?
Compute abstract method.
Okay, so we just need to declare one abstract method, and public method abstract, and it will return long, right? Name of the method is compute, and takes two parameters, long minimum balance and the long for the current balance. Yeah. Okay, so this is sufficient. Okay, fine, though we may need a few more things, and but this is what was expected, and this is to be saved as penalty.java. Okay, fine. And okay, I think we something is pending in the. Yeah, here we need to now we can do something like this. We can say, okay, let's have two parameters, minimum balance and balance. Okay, given minimum balance and balance, fine. So here I'm setting an object of penalty. Okay, fine. I'm setting the object of penalty, and what's a penalty object? It will say, okay, here I should do a check that only if minimum balance is greater than the balance, right? Okay, only in that case, if minimum balance is greater than balance, only in that case it should be, maybe I want a fixed value 100, otherwise a 0. But this now becomes a sorry, this now becomes a functional interface. So penalty is now a function. Okay, fine. It's there written as a function, right? It's a function of minimum balance and balance. Given minimum balance and balance, we will compute the penalty. Fine. Fine. You know this lambda expression now, right? Okay, so lambda expression is a function which is taking two inputs and then computing and returning the, so computation is, so the computation will be, let's see. My classmate, my classmate. Okay. Okay, so we have clear. And is this clear that penalty is now is a function?
Yes, sir.
Okay. Now let's see how we can make use of this. So currently what we have done is by default, right? So by default initially the penalty function is set to return 100, fine. Otherwise, and if penalty is not applicable, it will say 0. Okay, fine. So now, okay, let's compile at least this and let's see that it's working. Okay, let's test account.java. Okay, public static set penalty and suitable constructor found for. Okay, let's check. This is it's in line number 9. Okay, let's check that line number 9.
Return type is missing.
We didn't mention the return type. Sorry. Setter method return type void. Yeah, thanks. Okay, fine. So this is compiling, and fine. So this would anyway. There are no changes we have done from point of view of functionality. Let's use that setter method now. Okay, let's make use of the setter method. Okay, for that, let's first run the example. Test account. Okay, so if I look at the test account, okay, sorting. Before all that sorting thing happened, yeah, passbook of change. There's no penalty anywhere. Okay, this is before penalty, and okay, so I think penalty is not applied in the current example. Okay, let's have somewhere that a penalty should happen. Okay, let's put that case here. Okay, okay, fine. So we'll have to change in the test account. So here's test account, and in the main method, what do we do in the main method? Okay, a current account has been created, okay, 1 lakh, and we call the display method. Okay, withdraw. Yeah, this is there. CA.display. But this output is not coming. Before penalty is CA.display, and we do a CA.withdraw, and we do a display. Where's this output of display? Okay, let's check again. I think I missed out or something. Before penalty. Okay. No, it's not showing. Okay. Yeah. What have we done? Penalty didn't get applied, right? We have withdrawn 91,000, but it's not showing this. Okay, let me check. Let me check again. Compilation. Okay, 91. No penalty got applied. Yeah. Okay, I think our function is probably wrong. We did some mistake somewhere in putting that function.
Sir,
Yeah.
sir, minimum balance is 5,000, so how will the penalty will apply?
Yeah, good. Yeah, I was thinking it is 10. Let's make it 10,000. Okay. Yeah, we'll make this 10,000. So then penalty will become applicable. Good. Thank you. Okay. So let's compile and let's run again. Okay. So we see this penalty is applied, right? Okay. So penalty of 100 is getting applied. 8,900 becomes the balance now. Okay. Yeah. So, okay. So this is fine with everyone, that yes, a penalty thing is working. Okay. Now, how do we want to use it? We want to use it here in the test account. Okay. Now that we have got the set method for the set penalty, yeah. Okay. So before I do a withdrawal, maybe I'll change the penalty function. So I can say set penalty, and here you can give a lambda. Okay, so I can say, okay, let's have minimum balance and balance given these two things. Okay, let's write a function, proper function, and we'll see what we want to do here. So this is anything, whatever way you like, you can test it. Okay, so one thing what we'll do is let's find the difference between what's a shortfall. Okay, so if shortfall, depending on the shortfall, we'll have to decide what is the. So what is the shortfall? Okay, minimum balance minus balance. Okay, and that is the shortfall. Oh, sorry. Difference is equal to this, and we can now say, okay, let's have if difference is greater than is less than or equal to 0. Okay, fine, we'll return a 0 if that difference is less than or equal to 1000. Okay, fine, then we return a 100 if difference is less than or equal to 2000. 200. Okay, then you might like to do some such function. and otherwise maybe return 500. Yeah. Okay, something like this can be done. Okay, now you can try what happens if you try to withdraw. Okay, here it would be 1000, so it won't change. Let's make it 93,000. Okay, fine, we are withdrawing 93,000. Let's see what's the penalty amount. Yeah, penalty is 500. Fine. Okay. Yeah. Clear? What is the idea? That this is now a function, it's not a fixed value. It's a function of what's your difference between the balance and minimum balance. Okay, and it can be changed. It's a function which we are able to replace with the help of setter method.
Yes, sir. Sir,
Yeah.
sir, can you just show me what changes you made in the withdraw method of current account?
Okay, sure. Yeah. Okay. We had done that new transaction, and then we were using a, I think, yeah. What we were doing was we were using just the value of penalty over here. And what was written here was penalty, which was actually a fixed value. But now penalty is a function which has a compute method, right? So we are just saying, okay, we have a penalty here is our function. Okay, so on that function, call the compute method and pass the value of the minimum balance and whatever is the current balance. Invoke that method. Fine, for penalty computation. And this is the change. Okay. And just said, okay, dot compute. Yeah.
Yes, sir. Got it. Thank you.
Okay. Clear? So how it has become a function instead of a fixed value. And that should be clear now. Okay. Any other to-dos which we have here? Anyway. Yeah. Any other thing which was to be done from yesterday's things? Okay, let's go through this. Equals, this is done. Implement the, okay, implementation of comparable interface. I think this has already been done. Okay. Use local date class. Okay. Yeah. Okay. This we have done already. In the transaction class, have we used local date? No. Okay. Fine. I'm just using that local date. Fine. Only the type is changed to local date. And okay, okay, what I'll do is I'll keep the old thing and comment this. Let's make the change here. Make this as local date. Okay. If it's a local date, your equivalent of system.current time would be local date dot now. Okay, then you can use this local date dot now. And we'll need the import for the local date. Let's see where all the correction related to this may be required. I think we have that printf method being used. Okay, what was the output? Let me just check the output of print passbook. It's printing the date, the year, month, and date. Okay, so that's fine. It won't matter. And keeping just the date and not the time component is okay with the kind of formatting which is done earlier. Okay. You are aware of the printf method, which is there in C language also?
Yes, sir.
Okay, fine. Now, if you want to read exactly how the format string needs to be given, because we have used it for printing the date, okay, formatting a date field. So if you want to know about it, you know where that documentation is available. I just pointed to you where the documentation you can read from. Okay, I'll just show it in that Java doc where it is available. Right? You have the class called, in the java.util package, there is a class called formatter. Okay, in classes, there's a class called formatter class. Okay, so just go to the formatter class, and here in the description part of this, yes, you'll find the entire description of how the format strings are created. Okay. Fine. The printf method, in the print passbook, we have used the printf method, and it is using this part. Okay. So when you have time, you can go through all this. Okay. Here are the date time conversions. Individual fields can be asked for, or there are those compositions. Formatted dates, and okay. And these are the date and time compositions. Yeah. So what we have used here is, I think, is this one. Yeah. F, capital F. TF. I think it is percentage T, capital F. That's what I would have written. And that's why you are saying the YY hyphen MM hyphen DD. Yeah. Year, month, and date. And that's a format which is selected. It is a ready-made composition which is available, and we are using it from this place. Okay. Fine. So this should be okay. Fine. So go through this part, and later. And we have this class called local date, which is in the java.time package. Fine. We'll see if we have time tomorrow towards the end, then I'll try to cover the date and time APIs, but we have a lot many other things to do. So okay, so any questions here? And how this change has occurred? Okay, so in the to do, let me just check this part. Add a method. Use local date, so that's done. Okay, and we have add a method called get transaction stream. Okay, when we look at streams today, yeah, then we'll make these changes. Okay, I think the following changes are once we have. Okay, these are all related to streams. Yeah, these other to-dos are related to the stream. Okay, in the bank also, did we have any change to make because of the function interface? Or anyone has tried any change in the list method, bank.java? Doing a for each as a method where we use a consumer. In the bank.java, we have these methods, right? The enum account type is fine, but we have open account. We have the deposit, withdraw, display, print passbook, which anyway calls. This is the method called list accounts. Okay, okay. Even in the print passbook, yeah, we could make that change here also, right? For example, if account is equal to null, then break. This is old code, I think. Yeah, this is not needed. This was not needed. When this was needed when we were using an array, because in array initial things would be there, but after that initial part we would have nulls in the array. Okay, so this was only for that purpose. Okay, and I'll just comment it out so you know that this was a change, but this change was needed yesterday itself, that we could have done this. Okay, we didn't need this. Okay, fine. Now since we are using for each like this, I think I've shown this yesterday in the example. Yeah, can we change this part? Okay, the for loop here itself, and can it be changed? Okay, let me. Yeah. Okay, so we can do away with the for loop like this. Okay, so instead of that entire for loop, right, we should be able to use, okay, this was a for which involved accounts, right? For each, okay, this dot account map dot values, yeah, this dot account map dot values, right? Account map is the map, values will give us a collection. Okay, on collection we can use the for each as a method, and for each, yeah, what do we want to do? We have to pass a consumer. What is it? This is fine. No for loop to be written. This is what we can do. You're just calling the display method, right? Okay, fine. So list accounts, I have updated the list accounts here. And we have used method reference. You want to keep the lambda version also? We can put, I'll put the lambda version of it. Equivalent lambda version was. And but I'm going to comment it out. Yeah. Yeah. So on a collection, you can use a method called. So this is the collection part. Okay. Fine. On a map, call the values method. It returns a collection of all the value objects, and then use the for each method. And in for each, just give what is it that you would like to do on a given object of the collection. So let's say, okay, just call the display method. Okay, so for each of them, call the display method. Okay, so your list account says one line for the header. Okay, one line for the entire fine for displaying all the elements, and just one line for the footer. Okay, 3 lines. Yeah. Okay, fine. So let's proceed now. Yeah. Fine. Any questions about these changes which we have done? Okay. Now let me talk about the. Please come back to the notes. And okay. Okay. Let's see the. Okay. Okay. So one thing is I have mentioned revisiting comparator, but I understand you do, have no knowledge about comparator as yet, right? Or you know comparator already. Have you used the comparator anytime?
No, sir.
Okay.
No, sir.
Okay, fine. Earlier, I think even on first day, we have used one more functional, one more interface, not function, but we have used one more interface earlier, and that was comparable. So we have these two interfaces, comparable and comparator. Okay, I'll just quickly talk about those two interfaces. Okay, comparable of T, of yeah T, and So these are two interfaces which are available. I'll give you both the method signatures. They are both having one abstract method. So I'll put the abstract methods here. Okay. So for example, we have one is in the java.lang. Okay. So comparable is in java.lang and comparator is java.util. Okay. So that's a comparator. Okay, so we have the public interface comparable of E. Okay, and this one has I'm only mentioning I'm not mentioning the public method called equals, which is also there as an abstract method in comparable. Okay, but it has this method public int compare to. It says fine, you compare. Okay, this is comparable of T and it takes T as a parameter. So this is the abstract method. Okay, now what's the use of this compare to method? Okay, let me also put the other interface. It has the public method. So that's the other method, right? These are the two interfaces with their own respective methods, like as given below above, right? And what we have here is the int value which it is returned, right? The whole idea here is that okay, this comparable and comparator, they both refer to comparison logic. Okay. So comparison logic for comparing elements of a particular class, of a particular type rather. Okay, so T is a type and I want to be able to compare elements of a particular type, and then we use this. Okay, but we can see there are two different comparison signatures. Comparable says, okay, compare to method is there with only one parameter, whereas comparator says, oh, we have two parameter method. Okay, fine. The first one, okay, comparable. Any class, where do we need the comparison mostly? Why do we need comparison? We need it for sorting. And so the place where we would use comparison is mainly it's a sorting, right? Only when you can compare, you will be able to sort it. Okay. Okay. Any class which has a natural ordering should implement the comparable. Okay. And so if a class has a natural ordering, then it should implement a comparable interface. Now let me ask a simple question. If I give you objects of account, I have got a number of account objects and say, okay, put them in order. I don't mention any other thing. I just say put these accounts in order. What would you do? How would you order them? These are account objects and you have to put them in order. I have not given you anything else, no other information. My instruction is put these accounts in order. How will you order them? Okay, yeah, we will be using sorting method, but suppose manually you've got, I've got so many account objects. Okay, fine. So there is, let's say, a slip for every account object with the information about the account. Okay, and I'm saying put these slips in order. These are account objects, put them in order. How would you order them? So I think normally you would be ordering them by their account numbers, isn't it? These are account objects. Each account has an account number, right? And you would find it that the most natural ordering which goes for this is by account number, right? Oh, these are fine. If someone says just order these account and doesn't say anything else, fine. Your natural tendency would be to order them by account number. So we say account have a natural ordering. Okay, fine. Account has a natural ordering because they have an account number, and we know we'll order them by account number by default. Okay. Now let me take another class. Suppose you have a class called color. Okay, and I say, oh, put them in order. How will you order them? We have got color. So how do you order colors?
with their hexacode names.
Uh, but hexacode names, but hexacode names are RGB. Oh, you want to give more preference to red? Do you think red is less than green, as less than blue? Is it like that? Do we want to order and say, okay, oh, we have an ordering here where green is smaller and red is bigger, or something like that? Do they have this kind of an ordering? Do the colors have such an ordering? No, we can't be saying something like this, right? That red is greater than blue or something on those lines. Yeah, it's so we said this doesn't have a natural ordering. So not every class has got a natural ordering. That's the point I'm bringing here. Okay, not every class has a natural ordering. If you feel that a particular class has a natural ordering, in that case, that class should implement the comparable interface. Okay, to indicate I have got a natural ordering. Okay, fine. So the logic of comparison is then available. So if you say, oh, I'm implementing comparable interface, right? So if we consider two objects of some comparable type, okay. Okay, so if A and B are two objects of a comparable, okay, then okay, then the following is fine. Then what happens? Like then it's something like this. Then if A dot compare to, because they are comparable, we'll be able to use the compare to method. If A dot compare to B is greater than 0, okay. So if A dot compare to B is greater than 0, and it's not a syntax that I'm using, I'm just putting a statement. So if A dot compare to B is greater than 0, then A is considered to be greater than B. Okay. If A dot compare to B is less than 0, then A is considered to be less than 0, less than B. So the comparison logic, fine. For natural ordering, the comparison logic is in the class itself, because the class is saying, oh, my objects are comparable, and I can compare it with another object. So give me the other object. Okay. And same way, if A dot compare to B is equal to 0, then A is considered to be equivalent. Okay, clear? The meaning of that int value, the interpretation of the int value which is returned by the class, and this is how it is considered. Okay, one more point, you know the wrapper classes. Okay, all the wrapper classes implement comparable. Okay, so if I say byte class, okay, it implements comparable of byte. So byte can be compared with any byte. It's like this. Okay, fine. So byte class would have a method called compare to, where a byte is taken as a parameter and it returns an int value. Okay, fine. To give you whether which is greater, which is less. Okay. Now coming to the class called arrays. Okay, arrays class has a method, has sort method. Okay. Okay. So we have the public static method in the arrays class, returns void, name of the method is sort, and of course before I specify the return here, I must specify the type. Okay, you can leave this, I think, in which case it says you can give any kind of an array. So given an array, if you are passing it as a parameter, it is assuming that you have these objects which you are passing, the array which you are passing has objects which are already comparable, and it will try to compare them. Fine, it will use the compare to method. Okay, so it is actually assuming that the array given is array of objects which implement a comparable interface. So if they don't implement comparable interface, it will throw a class cast exception because it's trying to cast them into a comparable. Okay, arrays class has another method. Okay, another sort method. So another public static method returns void, name of the method is sort. Okay, but in this case, yeah, I have a type parameter t and says, okay, you want to sort, you can sort an array of type t. Okay, provided you can give me a comparator of t. Here it is using question mark super t. Okay, so this is your other comparator. Yeah. Oh, what is this comparator now? Yeah, comparator of t. Right. What is the method? Now, how do we interpret that integer value? Given a comparator c, okay. See, the idea here is even if something is comparable or may not be comparable, fine. So account here is comparable, that's fine. But irrespective of whether it was comparable or not, someone would say, okay, I would like you to put all the account objects in the order of their names. Right? Someone else may say, no, I would like it to be ordered by their balances. So you have different comparison logic. So for each comparison logic, you have a comparator object. Okay, fine. So if there is a comparator object C, okay, so given a comparator object, okay, C, okay, if C dot compare A comma B is less than 0, okay, then A is less than B. In same way, so if C dot, so we have the method called compare here, okay, A comma B is greater than 0, then A is considered to be greater than B. Okay, and if C dot compare A comma B happens to be equal to 0, okay, then A is equivalent. Okay. Fine. So what we need to do is we can create different comparators for ordering by different criteria. Okay, you can use comparator to compare by different criteria. Okay, so create different objects of comparators. That's our whole idea here. Yeah. So comparator, yeah, what are the, okay, so in comparator method is known, compare method with two parameters. If it's a comparator of t, the parameters are of type t, two parameters, but compare method has two parameters. Okay, fine. So if you want to sort, yeah, okay, yeah, one more thing. I've used question mark super t. Yeah, what is this question mark super t? I didn't explain when we were looking at generics. I did explain about question mark extents, but not about super. Okay, so when you say this is comparator of question mark super t, okay, it would mean give me a comparator for the type t or a comparator for any super type of t. Okay, fine. What qualifies here is a comparator of t or a comparator for a super type of t. See, for example, if I have an array of current account, okay, you got an array of current account, and but the comparator which I'm having is not for the current account, but it is for the account. If there is a comparator for account, can I not use it to compare the objects of current account? It should be allowed to be used, right? So that's what we are doing here. Okay, see, consider t as a current account. The t is a type current account. Okay, but when I need a comparator, I can say, okay, you can have a comparator of account also, and that should also qualify here. And that's why we are mentioning question mark super t. Okay, if there is an array of account and someone says, I would like to use a comparator which is meant for a current account, no, then that's not going to be correct. Okay, that cannot work. Okay, so this has to be a question mark super t. Okay, so comparator of t or comparator of any super type of t. Okay, that's what is meant here. Okay, so clear what is the idea about a comparator, right? And mainly we use it in the sort. Okay, because comparator will be also quite helpful to you. So many things you will need sorting at so many places, and I'll explain how creating a comparator has become much easy. Earlier, prior to Java 8, it was very difficult thing to create a comparator. Okay, and no, I won't say very difficult, but yeah, it required creating an anonymous class. I think you're aware of what is an anonymous class. Yeah.
Sir, here what is the super type of tree?
A super type of T, object would always be a super type of T. Okay, fine. So it all depends on T. So if you assume T is current account, fine. Suppose T is current account. What's a super type of T?
Objects.
Direct super type, account. If T is current account, assume T is current account, then super type is account. Another super type is object. Of course, object is always going to be super type. So if someone has a comparator for object, oh, that's also fine. Because someone may say, oh, I'll always order them by the hash code. Fine. If someone wants to say, I want to order ordering based on the hash code value, I don't look at anything else. Okay. In that case, so, you can have a comparator which works for any object, right? So if I have this comparator which works for any object, okay, it can always be used to compare account object for any kind of things, right? So that's a comparator of object. And so someone can have a yeah.
Sir, to order the classes, can we use the ordering class present in comparator interface?
To order the objects of a class, you can use the
Order the classes.
order the classes.
Ordering class. Yes.
Which one is the ordering class? I didn't get, sorry.
It is in comparator interface, I think.
Comparator is the interface. Yes. And I'm not getting a class called ordering. You mean the class called ordering?
Yes, yes, there is a class name ordering.
Okay, we have this comparator of t, right? Okay, so within this comparator of t, you are saying there is some class called ordering. No, we don't have
Yes,
any.
to
No,
order the classes. No,
no, to order the classes, no, we don't have anything like order the classes. You order the objects of a class. Okay, put the orders for the objects of a class, right? So this is what is the method which can do the sorting if it's in an array. Okay, fine. Same way, I'll tell you another place, like this is arrays class. You have the class called collections also. Okay, so even in the collections class, you have a method, and there is a public static method, and parameter would be yeah, this is a static method which can be given a list of. Okay, so here would be the type parameter is t. It says, okay, give me a list of some type t, and comparator of question mark super t. Okay, so that's a comparator which you are giving. So you use like you can order array here. In the collections class, you can order a list. Okay, and another thing which was done in Java 8, because this method existed much earlier. Okay, it's there, I think, right from Java 1.2, but we do have another way of ordering the list. As far as Java 8 is concerned, in the list of t, okay, if there's a list of t, in that interface we have a public and default method. Okay, returns void, and name of the method is sort, where we can pass a comparator of t. So you need a comparator in order to sort them, because that provides the logic of ordering. Okay, fine. Comparator has lot of methods which actually I want to discuss now. Yeah, okay, but we don't have a class within comparator. Okay, fine. We are always going to be ordering the objects of a class, objects of a particular type t rather, right? So if you have objects of a type t, they can be ordered. Okay, and how do I compare two objects of type t? That's a logic in the compare method of comparator. Okay, fine, clear? Okay, so we don't have anything, any class like ordering or anything. Okay, yeah. Okay, let's check this. Since if you're saying we can check this, we can check it here if you want. Yeah. Okay. So we have this package, Java util package. Let's go to the classes and interfaces, and here we have the interface called comparator. That's the interface comparator, and yeah, are there any member nested types? No, it doesn't have, and there are no nested types here. And so this is, yeah, you can see this. It directly comes to methods, and lot of static methods. There are instance methods and a few default methods and some default methods as well. If you look at abstract methods,
it might be in object classes. It might be in object.
Object class has a method for equals. Okay, fine. See, this object class has a method called equals. There's one more point which is related to comparable interface. So if you are saying your class objects of a class have a natural ordering, then your compare to method should be consistent with the equals. You try to keep it consistent with the equals. The idea is if equals is saying they are equal, right? Your compare to method should return a 0. Okay, so equals and your compare to, they should be consistent with one another. Fine. Okay, so that's the other thing which is needed, but we don't have a class called ordering. No, we don't have any such thing. Okay.
Okay, fine.
Yeah. Okay, so let's look at this comparator. Yeah, we were looking at this comparator. We can have a look at the methods. I think I'll start with that presentation slides of the presentation. Yeah, yeah. Okay, so there are lot many things to be done. Comparator. Yeah, we want to. Okay, now these are the things which actually we would like to look at, right? Before we go to the streams. Okay, so here is comparator. We have the factory methods. Now, when I say factory method, what do you understand? And what do you understand by someone saying, oh, factory methods? Because that's a terminology you might come across. Design pattern, you understand design patterns? So there's a factory design pattern. No, no idea on that. Okay, so you have many places, there might be many classes where they provide a static method. Don't use the constructor, but use the static method to create objects. Okay, fine. So these are some static methods useful for creating the objects. So if you want to create a comparator, there are many useful methods, and now just pay attention on how simple it is to create a comparator. Okay, fine. We have some ready-made methods, static methods available in the comparator interface, which help us to create a comparator quite easily. Okay, fine. So if I okay, let's do this. Fine. So let's look at the static methods which are there for creating a comparator object. Okay, fine. Static methods. Okay, I'm not going to repeat the word static with each and every method now. Okay, fine. All your methods are going to be public and static in your. So we are talking about public and static methods. Okay, fine. So we have method. They have this type T, for example, would return a comparator of T. Okay, so you want to create a comparator for account? Yes, we can create a comparator. T could be account, T could be whatever class you want to have. Okay, so you can create a comparator to which orders by a particular field. Okay, so how do we do that? Yeah, so comparator method says, okay, you can use the method comparing. Okay, where yeah, T is a bounded type parameter, and it says it extends. So this is a bounded type parameter which says extends comparable of T. So if it is a comparable type, okay, we can create a yeah, okay. I think we have T and U, two type parameters. T and U extends comparable of U. Okay, and we will get a comparator of T. Okay, if you use if you can pass if I can pass a function which takes T and returns a U. Okay, this is your mapper function. Okay, I explain what this actually means and how we use it basically. So for this, you can consider we have this class called account, and you want to have ordering by name. Okay, so I can create a comparator of account. Okay, name wise, name comparator equals, and if I want a name comparator, I can say, okay, fine, let's have comparator.comparing. And now what does it need? It needs a function which takes t. T here is account and u could be the string type. Okay, fine, string is already comparable. Fine, so you're saying, okay, we'll say comparing, and as a parameter, I need a function. So what is that function? Given an account, okay, get it into the ac.getName. Yeah. Oh, so then this will be a comparator which compares by name. Okay, or you want to write it in another way. Okay, it could also have been written as and instead of a lambda, I could have written account : get name. Comparator.comparing account : get name. So that's a comparator which compares by name. Okay, fine. How do we use it? So if you got an array of account, okay, so someone says, I got an account array. Okay, let's not worry about this. So how do I sort? Arrays.sort and accounts, comma, comparator.comparing. Yeah. And this is going to sort my accounts by the names. Clear? See, I have given an example of name because here name is of type string. String is already comparable, and that's why we can do it like this. Okay, we have similar thing. Instead of a field being of type string, which is a comparable type, if we had a primitive type, okay, which is byte, long or double or something like that, int long or double, and we do have another version of the comparing method. Okay, fine, we have this as a static method, right? So let me put the other static method now. Okay, so we have another static method where okay, we'll just talk about t. We don't need all of this. Okay, so there's one type parameter. You want a comparator of t. Name of the method is comparing int, and the parameter to that is the toInt function of t. So given a t, okay, I can convert into a int. I can get you an int for it. Okay, fine. Same way, other two static methods which are available. We have the method called comparing long. Okay, this would take the toLong function. And that would take, that's a method name is toDouble from comparing double. Okay. Right. See, when it's a toInt function, that means input is a t and return type is int. Input is t, return type long, that's a toLong function. toDouble is input is t and return type is double. Okay, fine. So similarly, if I wanted, okay, I'll just write the equivalent thing. Okay, so how do we create comparator? It's so simple now. I want to sort, yeah, comparator.comparing, and okay, I have got the get balance method, and balance, what is get balance returning? It's returning a long, get balance is returning a long, and therefore I can use comparing long. Okay, so that's how I can sort account array by balances. So simple. Normally, any class you want to order by a particular field, you can do it this way. Okay, so we have the method called comparing, comparing in, comparing long, comparing double. Okay, depending on which type of attribute it is. If it's a comparable type, yeah. Okay, so the corresponding getter method, fine, that will give us the comparator object. Fine. Arrays dot sort, yeah. See, the whole point is that the function which is passed is converting from a given type T to a type which already has a comparison available. Okay, int long double, or they are numeric type, they can always be compared, right? And if it's a comparable type, oh, then there is a comparison available. Okay, so the idea here has been to convert into a form for which comparison is already available. So a function input is your type T because you want a comparator for T. Okay, right. So this we understand all of these methods, right? But now another one which is available as a static method is given type T and U, where we are not saying U is comparable, right? But you can get a comparator for T, okay, using the method called comparing, where we have the function from, fine, which can convert from T to U. Okay, that's our mapper function. But for this, you will also need, because you're not saying U is comparable type, so you need to provide the there is a comparison logic, okay, available for U. Okay, so you already have a comparator for the type U. Okay, and the type U has a comparator available. In that case, you can create a comparator for T. If you can convert, you have a function which takes you from T to U. Okay, so there is some attribute, maybe that attribute may or may not be comparable, but you have some other comparison logic. Okay, fine. I'll show you one simple example for this one. Okay, where we might use this. Okay, you're aware of the string class? Yeah, fine. We have used the string class, right? Okay, string
Yes, sir.
is implementing comparable of string. It has the method called compare to. Not only that, string class has a static variable. Let me put, so in the string class, fine, within the public class string, okay, fine, it implements so many things, right? But within this, one of the variables which I'm interested in now, it has a public static final. Okay, the name, the type of the variable is comparator of string. Okay, and name of the variable is case underscore insensitive underscore order. Okay, equal to, and some initialization has been done here. Okay, fine. So we have one variable called case insensitive order. It's a static variable in the string class. As the name suggests, can you guess what it is for? This is a comparator. What is the logic of comparison? This method you may be aware of. Okay, public int compare to ignore case. Are you aware of this? Given a string s, yes, it will return an int. So this is your comparison logic, but it is case insensitive. Fine. And there is a compare to method because it is comparable, but it even has a compare to ignore case method. So if you ignore the case, right, then so case insensitive comparison can be done. Okay, so now I want to order my account array by names, but it should be case insensitive. So if I want that, yes, this is what I'll do. I can say arrays.sort comparator.comparing, and no, it's not about comparing long, and yeah, account : get name, because that's a field I would like to sort on. Okay, comma, I'll say string, because this get name is returning a string, right? And string dot case underscore insensitive underscore order. Right? So that's how you can use your case insensitive ordering by names. Yeah, okay. It's not sensitive to the case. Okay, it's a case insensitive ordering. And clear. So this is another static method which we have used, comparator. So comparator has such static methods. Okay, comparing int, comparing null. Static methods create objects. Right? So if I come back here, so comparing and variants of primitive types, that comparing int, long, double, right? Also, we have another set of methods. Okay, again we are talking about comparator interface, static methods, public and static methods again. Yeah. So in public and static methods, in that same list, we have a method with, okay, for some type t, you can get a comparator of t. Okay, name of the method is natural order. Okay, now this works only when the t is a comparable type. So it says fine, here is a comparator which will order based on whatever is the logic available in the comparative method. So it must be a comparable type. So whatever comparable is giving, I'm giving that same ordering. Okay, fine. So one is a natural order, another method is a reverse order. And so these are two methods. So one will give you ascending, the second one will give you the descending ordering. Okay, fine. But according to the comparative method, fine, depending on the comparative method available in the type T. Okay, so T is a comparable type. That's one thing which is assumed here. We have the natural order and reverse order. Okay, another set of methods. Okay, now yeah, one more thing. Suppose I had this account array, okay, equal to, I'm putting, so you got a lot of account elements which are there in the array. Okay, there's so many things in the array, but maybe there is a null also somewhere in the array, and there are more elements, and then we have null again. Okay, the point here is, if I have got nulls in my array, right? Okay, so if I got nulls in my array, and if I give it for sorting, yeah, it will try to invoke the compare to method or the compare method involving the null element, and that by default normally would be throwing an exception. Okay, so what you can do is, you already got a comparator where you have not taken care of nulls. If it's a null, then what should I be doing? That's a problem, right? Okay, does it become less? Is null less than the given element, or given element is less than the null? Okay, so null should be considered less, or given element should be considered as less. Okay, so accordingly what we have got is, we have got these static methods, okay, which can take t to return a comparator of t. Fine. Name of the method is nulls first, and parameter is, you have some comparator in which the logic of comparison is not given, is not taking care of null. There is a logic of comparison, but it is not taking care of null. If there is a null, it will throw an exception, but then it can be used for creating a null safe comparator. Okay, so I'm saying nulls first, and same way there's a method called nulls last. So these methods help you to create a comparator which can handle nulls also. Okay, it doesn't have any other logic. It has, when it's only adding on top of the logic which you have given. You have given a comparator, that means you are giving a logic of comparison. So you have given a logic of comparison. It's not handling nulls. So if you say nulls first or nulls last, accordingly, there is a comparison logic for null now added to the comparison logic we already had. Okay, so whether nulls should be becoming less than everything else or null should be becoming greater than everything else. Okay, so this is what is a null safe comparator. Okay, we call this as okay. So we got these null safe comparators, right, which can be created like this. Okay, fine. Now another one here. Okay, so null safe comparators. This is done. Yeah. Okay, fine. We have some more methods to create complex comparison logic. Okay, and for example, there are default methods. Fine. For example, when you are ordering more than one items, right? You want to have it ordered by names, but if the two names are equal, then we want them to be ordered by the balance. Right? You want to be ordering by one comparator, and if according to that comparator two items are equal, then apply the other comparator. Okay, another comparator to order the equal things. Okay, fine. So for that we have this method, a default method called then comparing. Okay, fine. We can also do a reverse. We already have a comparator. Call the reverse method on that, and it would do the reverse comparison, like ascending to descending. Okay, so ascending to descending can become descending to ascending just by calling the additional reverse method on the comparator. Okay, fine. Some default methods. Fine. So if you are saying default methods, they work on the object. Right? Static methods don't work on the object. Okay, so if you already have a comparator, okay, fine. So in that case, yeah, you already have a comparator and you are still wanting to have another comparator for the same type. So comparator of T only will be returned. Okay, but this one is a default method. Let me just put default first. Default returns comparator of T. Okay, because you are already having the type T in your object, right? So default method to return a comparator. Name of the method is then comparing. And you can pass another comparator. Okay, so there's a comparator to be combined with another comparator. Okay, fine. So you had a name comparator, you had a balance comparator. Okay, so for example, right, you had created a name comparator. For example, it would be a comparator for account. That's a name comparator. We have done it earlier. Equals, and you might be using comparator of name comparator is comparator dot comparing. Okay, when this was done earlier, and on similar lines, yeah, maybe we had another comparator. Let's call it as a balance comparator equal to comparing long, and that was taking parameter as get balance. Okay, so we had two comparators, right? One for name, another for balance, and you can create a comparator of account, okay, name, then balance. So if name is equal, then use the balance, okay. So this can be done by using name comparator. So it's a default method, work on the object, right? Dot then comparing, okay, and here you can say balance comparator. So we can combine comparators to create another comparator, okay, fine, connecting two comparators. So when you have comparison to be done on more than one field, this is the way you might be able to do it. Right. Okay, so these are some methods from the comparator. Okay, and so there's a to do for this, and so that's something which you should be able to do, right? I think whatever example I have taken, mostly it's on those lines. Okay, let's check the other things. Okay, we have this problem of null pointer exceptions. Yeah. Okay, so from Java 8, they have introduced a class called optional in the java.util package. Optional of some type T. Okay, so there is this class called optional. Okay, let's see what is this for. What's the purpose here? Yeah, why do you get null pointer exceptions? What's the main source of getting null pointer exception? Yeah. Why do we get the null pointer exception? Anyone? Yeah.
When we do some operation on null.
Yeah, and why that normally happens. Let's understand with a small example why that thing happens. Okay, fine. See, for example, suppose I understand that okay, we have this class called account, and in account we have kept only three fields: account number, name, and balance. But suppose we had a fourth field also, okay, and that field was something like we have account number, and then we have the name, and we have the second holder name. Oh, there's a first account holder and there's a second account holder also. Okay, now some accounts may not have the second account holder, right? So we have our class account. I'm not writing the whole class, but just to try and explain what I'm trying to put at, we might have, so we may have added one more, I'm just putting the additional field here, type string second holder. Okay, fine. So this field may not always be getting for all the account objects. All account objects may not have the second account holder and may remain null, right? Okay, and you have provided a method public string get second holder. Okay, and you might have simply written it as return. Okay, this dot. Okay, fine. Something like this may have been done. Okay, and that's very natural, right? This is how we may be writing our code. Now, what happens because of such a thing is this: somewhere else, someone who is writing a code, okay, so someone is using this class, he says, oh, I have got an account object is equal to my got an account object, and he says, okay, system dot out dot println, okay, size of second account holder's name is, and he says, okay, AC dot get second account holder, second holder name, sorry. Okay, dot length. I just want to print the length. I'm not interested in printing the name, but just the length. Yeah. So if you have written like this, yeah, what's happening? If this one is null, right? If this one is null, invoking length on that would throw a null pointer exception. And why did that happen? Because the one who is using the get second holder name, the method called get second holder name, is not aware that, oh, this can be null also, right? This can be null. If he was aware that this can be null, okay, basically, the point which I'm trying to drive here is that when we write methods, okay, we have methods which may be returning null. Okay, they may not return an actual object, but they may return null. Then the user of that method, he is not aware that this can be null also. Fine. He may or may not check. Fine. He may be aware. He may not be aware. If he is aware, he is a good programmer, and maybe he is. He might do his checking that yes, let me check for null before I invoke a method. Okay, but somewhere else someone says okay, may not be aware, and he doesn't check for null. So when someone invokes a method, right? So this is where the problem starts, right? So the problem starts because you have a method which can possibly be returning a null, but there is no indication from the return type that oh, this method may be having a null also. This particular thing which I'm asking for may not have a value. It's null, right? How do we indicate that this is null and it's not a value without actually returning a null? And that's where the optional comes into picture. Okay, fine. So now what I would do is I'll rewrite this part. Okay, let's do a total rewrite of all this with a change. Now see, what is the change which should be done? It says, no, I'm not returning a string. See, the one who is writing a method is aware that this can possibly be null. Then what he should do is he should not return the string. He shouldn't keep the return type as string. He should say, oh, this is an optional field of string. And no, you can't be returning it this way. And we'll see how we can return this. Okay, we have some, it will be saying optional dot of the label. And that's how you can return. Okay, so if this is how a method is, right? If your methods which are possibly possibly giving out a null, if they use a code where they change the return type and mention it as optional, the user of this method is aware now, right? He is aware this code will never compile, right? The compiler itself finds out, oh, that's an error. Fine. This is not a string. We can't use the length method on an optional object. This is what is get second holder name. Oh, it's optional. It's an optional which may have a string, okay, or it may be empty. The optional class is something like a box which may remain empty or may have at the most one element. When clear what is the idea of optional and why the optional? The idea here for optional is we don't use it as instance variable anywhere. Okay, that's not the idea. Someone could have said, okay, let me keep this as private optional of string second holder name. No, it's not for that purpose. The purpose here is the method's return type should change. Okay, fine. Your fields can be the way they are. Okay, but just change the method's return type. Make it fine. So the one who uses this method, fine, he immediately realizes, oh, this one, I need to be checking it. Fine, because it return type is not straightforward. It's saying it's optional. It's not saying it's optional, and optionally, whatever it contains is a string. In this case, we have taken a string. Fine, but it would be the appropriate thing. Fine. Whatever that method was originally supposed to return, okay, we'll say this is optional.
Sir,
Yeah.
sir, can't we typecast here?
Typecast into what? From
Can we implicitly typecast the output of that method?
I think typecasting the output of method. Okay, can you suggest what is the change you would like to have by doing a casting? Where do you want to do the casting? Somewhere in this line, the user of this method. Here you want to do a casting? Is it here?
Yes, sir, but not
Casting.
in the length method.
Yeah.
Means if any means you said now we can change the return type of a method. So instead of that, if we do the typecast, wouldn't it would be better?
You want to change it
Means
in the, from this one. This one, can you suggest the change you are suggesting? Yeah. Yeah. Okay. Something here you want to change? Casting somewhere in this. This is the original one, right? But
yes, sir.
so now, what is the change you would like to do? Is the change in this class, or are you suggesting change in the way we're invoking the method? I'm not getting the point exactly. So, where do you want to use the casting? This was the original problem, okay? Fine. And this is the suggested change because of optional. Okay. Now, because it is optional, this statement here is no longer valid. Okay. You can't be calling the length method directly. You would first be using some other method of, okay, for example, I'll just give it as an example, but don't take it as a case here. Okay. May not be correct thing because there are some other things which can also be done. Okay. Instead of get, okay, or else, and yeah, that could have worked. This or else is a method of optional. Okay, but the whole point is, yes, you won't get null pointer exception if you have done the coding like this. And the one who is using the method, the one who invokes the method, is also becoming aware that there is a possibility of a null. Fine. Fine. See, if I use the, I was suggesting a get method, but get would throw a null pointer exception if it was null, if it was empty. The optional object is either empty or has an object. The optional object contains one item or is empty. That's a case. Okay. And so this is the new class which has been added from Java 8. The purpose why it has been added is this: to make the invoker of a method aware that he may get a null here. So the return type should be changed to optional. Okay, I'll give you another example of a method where, okay, so you have a method, there's a method which says, okay, do a binary search. Yeah. Okay, so you might have a public, or maybe finding the min value. Okay, public method returns, okay, finding the minimum object, or maybe even if it's int, yeah. Okay, method name is min, parameter is int array. Okay, and you have an array, find the minimum and return. Yeah. Okay, fine. So someone has written the method, you have the whole logic of finding the minimum, right? Okay, and the one who is invoking this method is saying, okay, let me invoke min, but I'm going to pass a blank array. Tell me what's the int I will get. And why should I get that int? Yeah. Tell me what's the x.
X is the variable.
Okay. What will be the value I will get for this array which is empty? I am passing an empty array, 0 elements.
Null.
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 Maybe it will return null
Why should it return null?
because the array is empty.
So array is empty. Why should it be returning a null? It is supposed to return a primitive value. It is supposed to return a int. Right? Int cannot be a null.
And
Okay, fine. So I'll just suggest the type here. Okay. Yeah, any suggestion? Because anyway, you are not aware of that. Like we have, I'll just discuss the class called optional of a generic type. We also have optional int. There is a class called optional int as well. And this is what is the suggested return type from my side. You get it? Okay. So you may or may not be getting a value. And that's where we say, oh, this method, you may not be getting a value here. So that's why I'm giving you an optional. My return type optional. Okay. So this is a new class. Fine. We have these 4 classes. One is the class optional, which is generic, optional int, optional long, and optional double. And for int, long, and double, yeah, we have lot many things which have come up. And getting the point? What is optional?
So then what will optional int will do over here?
Okay, so that means what I will be doing here is, right, I should be using a method. It won't be an int. I can't take it into an int. If I want into an int, I must use some more method, because what is the object which is returned by main method? An optional int. Then I should be using a method on optional int. Maybe here also I might have a or else. Okay, and yeah. Fine. So we'll see. Let's see the methods which are available for option, because equivalent methods will be also there for the optional int, optional long, and optional double. But idea of optional is fine with you now. Normally you have a value, but there are times when I may not have a value for you. My return type can't be changed to not return something. Java is strictly typed language as opposed to Python. For everything, type has to be there. So here is a type which is suggesting, in this you may or may not have a value. And then if you get an optional object, you can, if it has a value, you will be getting it by the help of a particular method, or else, and then you might, okay. We'll suggest something else right here, or maybe instead of or else, there is some other way you would like to have it processed. Because you can't be saying it's the minimum is 0, or yeah, the minimum value in this is 0. Okay, fine. So let's proceed. Fine. Clear the idea of optional. Why optional? Okay, let's check the methods here. Okay, so one is how to create object of optional. Okay, fine. And then we'll look at the one who receives optional. How does he use it? So these are the 3 methods. If someone wants, he can. If someone uses the so 3 different methods: optional.off, and oh, sorry, I have not mentioned the parameter. In the first one, of and of nullable, the first and the third methods, okay, there is a parameter, the type is t. Okay, they take t as a parameter, those two methods. Second method, which is saying empty, yes, it's returning, it's definitely empty. When I say off, it will throw an exception. When I use the off method, it is expecting a value to be given which is not null. But if you are passing a null in the first method, it will throw an exception. Okay, and off nullable, it won't give an exception. You may give null or may not give a null. Okay, so to create optional object, these are the three options here. There's no constructor available. You have to use one of these three methods. Okay, first and the third method, they take a parameter of type t. Fine. Okay, now these are some methods of optional. Okay, so one is a method get, but this one will throw an exception if it is empty. Okay, fine. So if you are sure, oh, this is not going to be empty, I'm very sure this is not going to be empty the way I've used it, you may go ahead and use the get method. Okay, fine. And then we have the methods like testing. Oh, is it empty or it is not? So two different methods. One is saying is present. Is it having an object? Is it having a value there, or is empty? No, there's no value available. Fine. Is present, is empty. Fine. They'll both give. One is giving true, then other will give false. Okay. Now another method is if present. Right? So if present says you give me an action which I should take if it is present, otherwise you're not doing anything. Okay. See, for example, here system.out.println, and you wanted to print or else length. Yeah, this one, let me put it now how it can be used here. Okay, what could be done here is you could have said ac.get second holder name. Fine. So this is optional object if present. Okay, in that case system.out : not system dot. Okay, in that case, if it is present, what I'll get? An account object, right? Now I'll get a string object s. Okay, s dot system dot out dot println s. Yeah, sorry, println s dot length. Use the length method. So when you are saying if present, right, the lambda which you pass is the one which will be used if the value is available. If value is not available, nothing is done. Yeah. So if value is available, this is what can be done. But if value is not available, nothing. That's a if present method. And if present, use a consumer and do some action. Okay. If present, fine. If present or else. Yeah. If present or else. Yeah. So what is if present or else? Fine. If present, right? And you could say or else. So in case it is not present, let me pass what should be done in that case. Sorry. Yeah, this one matches which one? Hey, I think we have one bracket less in this case, right? Yeah, here it is. Okay. And this is the one. Right? So one parameter to that was a consumer. Second parameter is a runnable object. So what is runnable? Again, a lambda expression can be given. Okay. So in runnable, you might say system.out.println no value. Fine. Yeah, no value. Yeah. And so that's how you can do. Okay. So if it is present, do this. If it is not present, then here there is no object available, right? If it is present, we have an object available, which is a string object. Okay. Fine. Action. Fine. We are having two different functions. One function suggests if it is present, use that object. Second function suggests I don't have any parameters now because it's not present. I will not have a value. But this is what is to be done. So you're writing a function. Fine. You are writing a lambda expression. Okay. Fine. One is runnable. Runnable is also a function interface. Fine. Single abstract method run. Here if present or else. Okay. So we have the method called filter. So filter is just from okay. What is a predicate? Fine. Input is boolean. Return type is boolean. Predicate means some input, but it would return a boolean. Okay. Fine. So you can apply a filter on a optional to again return optional. So you're enhancing the optional. Okay, we have the optional, but if the length is less than 2, okay, I don't think it's correct, right? Second holder name length is less than 2. I don't want to consider it as a object, but let it become empty in such a case. Right? Okay. See, for example, here, okay, ac.get second holder name dot fine. On this I'm saying filter. Okay, and the idea of filtering here is that yes, if it is present, okay, fine, I have to give a predicate. So if it is that string s, okay, only if s dot length greater than 2. Yeah, so that's what I have suggested. So what it becomes? It becomes, again, it remains an optional, but in this case, anything which is less than or equal to 2, length of string is less than, second holder name's length is less than or equal to 2, will become empty now. Okay, so you are, whatever, though it was present, but it was some junk which was present. According to me, 2 or less is not a valid second holder name. Length of 2 or less. Okay, and therefore I just want that to also be, I don't want it to be processed. If someone is looking for the value, okay, let it be considered to be an empty optional. Okay, fine. So here if I ask for is empty, yeah, so you'll only get those where the length is greater than 2. Fine, otherwise it is an empty one. Here enhancing the optional object, and just making change on the optional object based on a test. Here are some more methods for optional. Okay. And again, this one map is again doing a similar from an optional of one type, it becomes optional of another type. Okay. From optional of T, you are making it optional of U. You had, suppose for example, you have an optional of account. Fine, you can extract the name and make it an optional of name, optional of string then, right? Okay, so there are two ways you may use it. You may use the map method or you might use the flat map method. In flat map, the function has to create the optional object, whereas in the other case, function is giving me the other type of object. Here the optional object itself has to be made available by the function. Okay, fine. This is the method called OR. Okay, so if I don't find it, I have a supplier who will give it to me, who will generate the value. Okay, stream we haven't seen. Okay, fine, we'll be looking at it. So you can convert it into a stream which will either be an empty stream or a stream with only one element. We have the or else method. Okay, so if it is not present, take this as the value. Okay, something like a default. I had written that code or else initially, if you recollect, where I suggested, okay, or else let's make it a empty string with 0 length. If it is null, let's make it 0 length string. And same way, or else get, or else and or else get. The difference is you need a supplier in case of a or else get. Okay, so whatever supplier is there, it will invoke the get method and get the value. And this is or else throw. Okay, so you can just say or else throw. That means if it is absent, throw an exception. And so it's exactly equivalent of using the get method. Or else throw. Okay, we have another or else throw, in which case the throwable, which is to be, what is the exception to be generated, you can decide. Okay, so you give a supplier for the throwable object, and so that's a or else throw. Okay, and so this is optional. Okay, another class which is there. Okay, another set of classes. We have summary statistics and a string joiner class. Let's see, there are three kinds of summary statistics object. And so that was optional. Okay, I have to introduce optional because in stream, when we look at the streams, okay, we will come across many methods which may have a return type of optional. So you shouldn't be surprised why that optional has come. What is that optional thing? Okay, similarly, there are many places where you will get summary statistics object. There are some methods which return this. What is summary statistics? Okay, so summary statistics, there are three classes which are the summary statistics. Like we have a int summary statistics, long summary statistics, and the double summary statistics. There are three such classes. Okay, and they collect statistics like count, sum, min, max, and average. Right? So they all have got a no argument constructor, and there are some common methods. Right? Some convenient methods here which are suggested are this. Okay? So, for example, in summary statistics, what are the methods we have? Okay, we have a method called accept. In fact, these summary statistics are also implementing the consumer interface. Okay, fine. So they implement consumer, and therefore they have the, so in summary statistics is an int consumer. It has a method called accept, which takes an int as a parameter. Okay, fine. There are two summary statistics objects, and they can be combined. And you're getting what is the summary statistics object? Okay. Yeah. Okay. What is the summary statistics object? Let's check this. Okay. A summary statistics is going to be something like this. So if you create a int summary statistics object, okay, and if this is one such object, what you do is you push integer values into it and just give it some integer value. What it is managing here are statistics. What are the statistics it is managing? It's managing fine. It's managing what is the count. Okay. It's managing what is the sum of those integers. It's managing what count, sum. It's managing what is the min value so far, what is the maximum value we have given so far. Okay. Right. So these four things is what it is managing. Okay, and given the sum and the count, we can always find the average, right? So what it has is internally it is maintaining just these four values, and internally this object has private variables for these four values. As you call the accept method, what it does, it will add into the sum, it will update min or max, it will increment the count and say, okay, fine, I have got that value. Right? So it just manages this, and anytime you can ask for, okay, I have given you so many values, give me the count. Okay, I have the count. Give me the sum. Okay, here's the sum. Fine. What's the min value? Fine. What's the max value? Fine. And what's the average? So if someone asks for average, of course that can be obtained. So we have the methods called get count, get sum, get min, get max, get average. Okay, fine, clear? Fine, a good class to manage statistics about values without storing all the values, right? Just 4 variables and you can manage statistics related to count, sum, min, max, and average. Fine. So it's just answering those things for anyone. Fine. So keep on calling the accept method and then fine, it's getting updated. Okay. Fine. If there are 2 such objects, again, they can be combined together, and so you have another object of option, and you can say, okay, you have another object of the in summary statistics. Those 4 values can be count can be added, sum can be added. Fine. Min and max, find the min of the 2. Max, again, go with the maximum of the 2, and of course, now you have everything again. Right? So combining all such things are possible, right? Fine, clear? So here are those methods, right? You have the accept method, you have the method called combine to combine with another summary statistics into this. Fine. Get count, get sum, get min, get max, get average, and of course there's a nice toString method which will show all the fields. Okay. Fine, clear? So this is also a useful class. Fine. So just like in summary statistics, there's a long summary statistics and double summary statistics. Okay, so these are some useful classes which you can use here. Okay, fine. Next is a class called string joiner. Fine. Creating a sequence of string joiner for creating a sequence of characters separated by a delimiter and optionally starting with prefix and ending with a suffix. We have the constructors and methods like this. So we have the constructors. A string joiner can be created from a char sequence by using just the delimiter. Okay, so if you just specified a delimiter, fine. You may, for example, commas separated. Fine. You got a host of string values. You know what is a char sequence? What because here what has been mentioned is a char sequence. Are you aware what is char sequence?
No, sir.
It's a name of an interface. Fine. Your string class implements char sequence. You know string joiner, not string, the string builder or the string buffer class. String is immutable, right? But the string buffer or the string builder, they are mutable. String is immutable, but those two are mutable. You can update a string buffer, but you know what is common across all of them? They are all char sequence. Okay, fine. So that's the whole idea, that we don't talk in terms of string here, but wherever char sequence is there, for your convenience, you can just think, oh, it's about string. So char sequence is an interface implemented by the string, as well as something like the string buffer and the string builder. Okay, so any of those 3 could be used here. Okay, fine. So you can give a delimiter, you can give delimiter, a prefix, and a suffix. Fine. And the methods which we have, let's see the methods. Okay, so here are the methods we have. Right? So you can use the add method. Fine. And so a number of objects of the string can be added. Okay, consider that char sequence as a string. Fine. So you can merge 2 char sequences, string joiners basically. Fine. Merge 2 string joiners. You can know the length of the string. Okay, and here is the toString method which will be giving you the output basically. Okay, and what you have is also a method called setEmpty. If there are 0 elements in the string joiner, I have not added anything into the string joiner. Okay, fine. In that case, what should be the string that should be displayed? Someone asking for toString. Okay, so fine. So fine. No values available or some such string message you would like to keep if there's nothing. Right. Otherwise, yes, comma separated strings can be there. Comma separated, no, delimiter separated. And in the starting, you want a prefix or a suffix. So those can also be specified in the constructor. Right. So Something equivalent of this is also available from the streams, and we'll see the streams. So this is string joiner, and now I think now we have to move to the streams. So any questions up to this point? Because now it's a new topic we are going to. And these were all small classes which were added. Okay, that's what we have seen. But now we have to look at the streams. Any questions? Yeah.
When it is required to use the optional class?
Optional class. Okay, I've given one example of min, max, those kind of methods. And they can say this is optional. I'm returning an optional type. So that it is possible for a method to say, okay, I don't have a value available, rather than returning a null which someone would try to invoke a method on. Okay, leading to the null pointer exception. So instead of that, it's better that this one says, no, I'm not going to, the method should be returning a null. And methods, because that's a point which is like, okay, which is creating all the null pointer exception things. Right? And that's one of the most common exceptions at runtime for Java programs. Null pointer exception, so many cases what happened. Okay, so to get reduce on that side, okay, because it's a misunderstanding between the one who has defined the method and the one who is using the method. Okay, the one who is using the method is not aware that, oh, instead of saying there's no value, he's actually returning null there. So we have an option of saying, oh, there's no value available. That's where the optional is. And the idea is, I don't have a value. When you're asking for a min, I can say, I don't have a value because there's no value which you have provided. And this particular account doesn't have a second account holder name available to me. And so where there is a possibility of something not being available, but normally you would have been returning a value, right? Don't change the return type for such methods and say they are optional. Right? In streams, you will come across many examples where the methods are returning optional.
So, sir, can we say that to prevent null pointer exception?
Yeah, it is just to try to prevent the null pointer exceptions which come. Yeah, I mean, that is the main purpose why optional was introduced. It was introduced the purpose to reduce the null pointer exceptions, possibility of null pointer exception. Yeah. Okay. Yeah. Okay, fine. So now let's proceed. Fine. Okay. So let's look at this is one of the important topics. Okay. One of the very powerful things added in Java 8, streams. Fine. Okay. So let's see, what is a stream? Fine. Stream is like fine. The purpose of stream is like building a pipeline. It's for creating a pipeline of operations and executing it. Okay. Let's see. Okay. Stream help us to create and execute a pipeline of operations. Okay. So that's a simple thing which I've put. Okay. We'll see what do we understand by building and executing a pipeline. We'll see all that happen. But as far as streams are concerned, there are types. There are two types of streams: sequential streams and parallel streams. Okay. This is one way of classification. Okay, we even have another type of stream which is unordered stream. That's also one of the characteristic of a stream: sequential, parallel, or unordered. Okay, I mean, it could be parallel stream and unordered. It could fine. Okay, so fine. So this is like okay. The type of stream is optional, and streams are available. Okay, so the type of streams. Another way of looking at streams is, as far as stream is name of an interface. Okay, we have this package called java.util.stream. Okay, so there's a separate package for this, java.util.stream. Okay. So streams are available for as a stream of the generic type, stream of T, that's one interface. And we also have these interfaces like in stream, long stream, and double stream. Okay. 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 Now streams, yes, if you are trying to use a stream, okay, there are three things about a stream. Every stream, fine. When you create a stream, we say, oh, we have to link it with some kind of a source. Fine. So when you create an initial stream, you must be linking it with some kind of a source from where the stream of objects will be available. Stream of objects or stream of the primitive types, int, long, or double. Fine. Accordingly, depending on the type of stream interface you are choosing. So creating a stream would be the first step. But once having created a stream, on a stream object, you would use either an intermediate operation or you would be using a terminal operation. So when I'm saying operation, I'm using the word operation to mean actually a method. So we have two kinds of methods available on a stream. Normally, we'll have only two type of methods. Okay, one is called intermediate operation, other is known as the terminal operation. Okay, so with the help of intermediate operations, you create a pipeline, you build the whole pipeline, fine. And once you use on this pipeline, which has been created using a host of intermediate operations, right, you might then apply a method which is a terminal operation, in which case it will execute the pipeline which was built using the intermediate operations. So intermediate operation builds a pipeline. Terminal operation executes the pipeline. Okay, fine. So yeah, this may be slightly confusing. So I think I'll try to explain it. Let me see if there's something here. Okay, let me explain what do we mean by what is the stream thing. Okay. Okay, all of you have, I think you're aware of, all of you have used Linux. At least sometime you might have used Linux. Okay.
Yes, sir.
Okay, on a Linux prompt, on the Linux terminal, okay, you get that $prompt, fine. And then what we can do here is many times the command which you might have done, you might have used a command which is something on these lines, something like, okay, I have some command number 1, okay. So consider some Linux command which I'm giving, and I use a pipe. Right, and I put another command, command 2, I use a pipe, I use command 3, and I can use a pipe, and I can use command 4. Yeah, what is this pipe doing for me?
Sir, it will act like if any input is going with the command 1, then the output of that will forward to command 2.
Fine. So output generated by command 1 becomes the input for command 2. I'll process whatever is given to me from the previous step. Right? Okay, fine. See, the command 1 is not going to be executing unless I have specified my final command, which is my command 4 in this case. Fine. None of the things execute, right? Only when I press enter after specifying all the commands, then we say the entire pipeline. This is a pipeline of operations. First is this operation, okay? Whatever generated by this operation becomes available for another operation, fine. Then it becomes available for one more operation, whatever is coming out from here, okay? And then I have a final terminal operation which will give me the result, right? What you see is the result of the entire pipeline, right? Okay, fine. So exactly similar things here. Okay, fine. Here we have a stream of objects. Okay, that means we need some source. Okay, so just consider like this, that I have a box kind of a thing, which is a stream is something like a box which will always have a input side from where it is going to receive elements, and because it's a stream, okay, it is going to be producing elements out of it. So maybe it is coming from somewhere, or maybe fine. But yes, there is always a output side. It has an output side. A stream has got it's like a box which has got an output side. Okay, fine. And how can this output be used? It can only be used by using one more box against it. Okay, and this box, right, will take this as the source, or this is my source. Right? The previous stream becomes a source for a new stream. Okay, what the previous stream has done with the whatever input it received, maybe it used some functions, right? If you know that function and lambda expression, that function objects, so it uses some objects to do the processing of that, and maybe it has maybe one or two multiple things. So it does something and generates new kind of objects, right? Because it is generating objects which are not yet available in the output, right? They have to be still to be processed further, and they are not the final output. They still have to be processed further. You will have to use another operation, right, which will do something on this, and maybe it might also generate an output. Okay, so if it is generating an output, yes, it's leaving something which is to be still consumed further. Okay, when it is giving me something which is to be consumed further, we say this is a stream object, and this is my stream. Fine. Okay, so from the stream I use another operation, I apply some more operation, but then this operation is not generating an pipeline which is to be still consumed further, but it is giving me a final result. Okay, it's saying, okay, here is the result you got. Fine. So that's done with the help of a terminal operation. So if there is a terminal, it won't result in a output. It won't result in a stream. Okay, I'll put one more thing about the methods of the stream. Fine. How do we distinguish between intermediate operation and a terminal operation? Fine. I mentioned about two types of operations. One is a intermediate operation. Okay, so if I'm using an intermediate operation on a stream, okay, so if we use an intermediate operation on a stream, a method is identified to be an intermediate operation if it results in another stream. So it would create another stream for me. Okay, it would create another stream for me. Right? So a method on a stream returning a stream, then it's an intermediate operation. A method on a stream not returning a stream, it's a terminal operation. Okay, so stream methods and methods on stream, either they are intermediate operation or they are terminal operation. Only there's one method which I have seen in the entire stream interface which is not falling in the two categories. Okay, it's not falling in both the categories. There is a method to return Boolean. Method called is parallel. This does not return a stream, it's returning Boolean, but it is not a terminal operation. Why it's not a terminal operation? Because it only talks about the kind of stream, whether it is parallel or not. Okay, fine, stream may be having a parallel nature, or it may be having a sequential nature. We'll see what that means. Okay, but fine. So identification whether a particular method is an intermediate operation or a terminal operation, identification is what's the return time. Right? But yes, this method, don't look at this method. This is not a intermediate operation, neither is it a terminal operation. But rest any other method on a stream, it's a, you identified because it's returning some kind of a stream. Oh, that's an intermediate, because if it's a stream, it needs to be processed further. There has to be something to be added further to it. Okay, because that output need, it is nothing. Stream is just one output side. Find output for a stream, someone to process further. Okay, I'm going to send you objects which need to be processed further. Okay, fine. So if, for example, look at this. I have some stream S1 dot. I use some intermediate operation. Okay, so it's like this. I'm just saying operation one. Okay, invoking a method, operation one. Fine, and this is some parameter, whatever necessary will be here. But when I use this, if it is returning a stream, then I will be able to use dot, okay, operation 2, which is another, maybe if it's a intermediate operation, yeah, I will be, maybe it has some more parameters to be passed. So this is still resulting in a stream, because operation 2, whatever that method operation 2 is returning a stream type. Okay, fine. Now suppose someone writes like this much, right? So this is nothing but returning a stream. So we'll be able to assign to a stream. Okay, we'll see what type of stream it is. So maybe someone says S3 equal to this, or S3 equal to S1 dot operation 1 dot operation 2. But what he has got? He's got a stream. Fine. So when a stream is created, okay, and you still result in a stream, you are only executing the intermediate operations. Fine. Nothing executes basically. This process is still about building a pipeline. We are setting up, fine, we are setting up these boxes in a sequence. Fine. Only when you call a operation which is a terminal operation on a stream, because it's not returning a stream, it's a terminal operation. Only when you do this, at that point, the entire pipeline is executed. Before that, nothing happens in the entire pipeline. The pipeline doesn't begin to use. When the pipeline is not getting used, it's in a phase where we say it's building the pipeline. Okay, so fine, you are just saying, okay, pick up the element which comes from the source, fine, and do this and put it for another stream. Fine, put it in a stream. Okay, fine. Whatever comes from, so someone says, else adds another operation, says, okay, whatever is coming in the stream, let me do one more operation on it and pass it further into a stream. So you can keep on adding more and more intermediate operations. So it's like multiple processing steps being created, being defined. Okay, fine, that's the intermediate operation. Fine, but at the end, someone will have to say, okay, let me use this terminal operation. When you use the term, call the method which is a terminal operation on that, on the final stream, fine, then the entire pipeline will execute. And we'll try to understand with some example also. But the concept should be clear that there are two operations, intermediate operations and terminal operations. Okay. Fine. Intermediate operations, we say we are building the whole pipeline. We are still further building in the pipeline. Okay. And so three parts to it, right? So fine. So one is a source, that is nothing but initial creation of a stream object initially, okay, which will decide from where the initial objects will be obtained from. Okay, and then we have the intermediate operations, which will just keep on building the pipeline. They don't do anything unless a terminal is applied. Okay, fine. So first part is creating a stream, then we'll look at building the pipeline using the intermediate operations. Okay, so creating stream here, how do we create a stream? So there are static methods in the stream. So you can create an empty stream with no elements at all. Okay, you can initially create a stream with only one element, or you can create a stream with n number of elements. Yeah, you can just by using the off method. Okay, off nullable is just like creating a stream which may either be empty or a stream with only one element. Okay, off nullable means that T here could be null also, it's fine. So if that T is null, when that element given is null, then it would be empty stream, or it would be a stream with single element if it's not empty. Okay, now here is another way of creating a stream. You can use a supplier. Okay, so you're saying, okay, whenever you need any element, here's a supplier, call the get method, and the supplier will get an object. When recollect, supplier type has a method called get, no parameters needed, but returns a value. So if you got a supplier created, yeah, then you can have a stream which will use the supplier to get the objects. It needs some source from where the objects need to be coming. Okay, fine. We have a method called iterate. Now, what is this iterate method? Okay. Iterate is something like we have a seed that is an initial value, and we have a unary operator. Fine. This is something like saying, okay, I'll show it in the text. Okay. Okay. So what is iterate, right? So if I consider something like this, what is this? Fine. It's a static method of the stream interface. Stream is java.util.stream is the package where we got an interface called stream of t. Okay, that's an interface. Okay, and the method which we are trying to look at is a static method. So it has a static method with some element type t. Okay, to create a stream, it would return a stream of t. Name of the method is iterate, and as a parameter you can give t, which is known as the seed, and you can get give a unary operator of type t. Okay, what they have called unary operator, they're calling it as a mapper or function. Okay, okay, fine. So this is the method for the iterate method. So how will the elements be generated in this case? So here in this case, the first element is the seed. Okay, what's the second element? It's nothing but whatever is the function dot apply. And uses the seed. What's the third element? Function dot apply. As a parameter, the previous element. Okay. When you get the point, what is being done? The previous element, call the apply method. When apply method returns, fine. What is unary operator? One input, one output, right? So input is the previous value, output is the new value which will be generated. So that would be used for creating the next element. So this is an infinite stream. Okay, it's an infinite stream. Fine, clear? Stream, how elements will be obtained. So you can create a stream which gives you elements in this manner. Okay. Fine, clear on this? What is the method called iterate? Okay, like it, we have a iterate method, fine, with 3 parameters also, where the second parameter is saying has next. Okay. Sorry. It says, okay, so one parameter is the seed, second parameter is not the unary operator, but second parameter is a predicate of T. Okay, that's a test, and it's a 3 parameter, right? So in this, the first parameter is equivalent to what was done. Okay, so yeah, as far as the things are concerned, what is generated is on these lines. Okay, but this is not an infinite stream, right? It would stop as soon as has next it returning a boolean. So if for the seed itself, even for the first one, fine, if we have test dot, the method name is test, right? Test, if only if test dot test is true, if test dot test seed is true, okay, only then seed will be there. Okay, the first element comes only when the seed returns true on the test. Test is a predicate, fine, call the test method. So same way, seed will come, fine. So it is able to give the first element, then fine, it will proceed for the second element. Fine. For second element, oh, the test will be applied on this. Fine. Whatever is the element being generated, see, it's like a sequence being generated, right? So on every element of the sequence, you are testing whether it passes the test, then only go ahead. Right? If that test fails, it stops there. So it's not an infinite stream. And this stream can be infinite because that test may always keep on generating true, but it has a possibility of an end, fine, because of the test. In the earlier case, it's not having an end. Okay, this one doesn't have an end. And so iterate methods is like this, and then we have even a method called concat. So you can concatenate two streams, okay, elements from this stream as well as the elements from the other stream. Okay, and same way there are so many others that this is from int. So the primitive stream, which is the int stream. So almost equivalent methods. I'll skip over this one. So even in arrays class, you have a static method. So if there is an array, you can convert the elements of an array into a stream. Okay, of course, we saw the method called off also, that could also be used. So stream.off, or you can say arrays.stream and give an array. Both cases, you will be passing an array. Okay, fine. These are some default methods in the collection. Recollect, in the collect, we had seen the collection, but in the collection, we didn't see the default methods. Collection has a default method called stream. So elements of the collection, they becomes the elements for the stream. So stream has number of elements. Okay, so you can create it as a sequential stream by default, or it would come, you can get it as a parallel stream. Okay, fine. And there are a lot many other methods where, for example, you have a use the Java you have done, right? So there is a class called buffered reader, and there is a method called lines. So buffered reader, you can recollect, it had a read line method. You have done, right? Java.io. Yeah. Yeah, have you done java.io?
Yes, sir. Yes, sir. Yes, sir.
Okay, fine. So you have this. So if you have a buffered reader, if you have created a buffered reader, fine, you could use the lines method to get a stream of string. So each line is one string, one element. So one element for each line. It's a string type. So stream of string. Fine. Lines method again available. This is in the java.nio package. Okay, in java.nio.file package, there is a class called file where we have a method called lines. So this is like from a file, all the lines as a stream. Okay, fine. Stream. So creating a stream is, you can find many sources from where elements can be picked up and stream can be created. And so these are just different places from the API which I've tried to pick up. Okay, fine. So, and like this. So even in the char, so char sequence, oh, that would give you an int stream. Char sequence is your string class, okay, string buffer, string builder classes. Yeah, you can use the method called chars, or you can use the method called code points. Right? That Unicode code point will be available. Okay, I'm not sure whether you have used pattern and matcher classes. So fine, that's for processing your regular expressions. Okay, in Java you can process regular expressions. So you have the pattern class. So there also, yes, we have methods which will give us streams and many more parts of the API. So in the API there are many places where streams are being made available. Okay, so many places are there where you can get a stream created. So initially creating a stream, fine, that's the first step. Okay, having created a stream, having got a stream, let's look at the intermediate operations which are available. Okay, so as far as the intermediate operations are concerned, we have a method called filter, okay, which uses a predicate. Okay, so it's like see, these are the intermediate operations, right, which will filter fine, which okay, so in a stream, like whatever is the, I have said, okay, in stream you picks up some source, right? The source could be a previous stream, if fine, if previous operation was an intermediate operation, or the source could be as decided by creation of the stream. So on a stream you are saying filter, and you are passing a predicate. Only those elements will go. So there is an input and output to this. So fine, like you can look at it as something like this. Okay, so if I look at a filter, okay, fine. We looked at a stream object. So here is a stream object. Oops. Okay, so if you have a stream object, fine, consider this has an input side, but it will definitely, because it's a stream, fine, it will come out with a, it's generating a stream, right? That operation is generating a stream. So it has an input, and this input is using a predicate. It uses the predicate, calls the method on the predicate. If the predicate says true, it returns true, or that will go here. If predicate is returning a false, it's not going in the output side. Fine. So that's how the stream is being used. Fine. This is one intermediate operation. So I'm creating one more pipeline. So fine, creating fine, there is fine. So someone else can add another operation to this, because I'm returning a stream, or there is some more operation to be done on that. It could be the next operation could be terminal or intermediate again. Okay, so filter is like using fine. So you passed a predicate, that would be used. So fine, this is one. Distinct means, okay, you're not putting that kind of a predicate, but what it is ensuring is in the output side I will not have any duplicates going out. Okay, your input side you may be receiving any elements, but the output side is not going to send out any duplicate. And if something is already sent out, okay, it won't be sending out that same element again, equivalent element again. And skip means, okay, whatever input elements I have got, I can skip initial whatever number you specify. So those will not be sent in the output. So maybe you use the lines method to read from a file, right? Fine. So you got the lines method, it's a stream of string. And on that you're saying, okay, I know the first 10 lines are some headers and I need to skip them. So you can just say, okay, file.lines.skip 10. So 10 will be the number of lines it would skip. Okay, fine. So one option is to say skip is like this, or your fixed number of lines. Another option to skip is a method called drop while. So what drop while will do? Every line, I'm assuming that yes, our elements are of type string, so there is a line, okay, which is reading line from a file. So maybe what you know is that I have got initial headers, and for end of headers I have a blank line there, right? So what I'll do is you keep on skipping, fine, you skip till you get a blank line. Okay, so you can use a skip while, drop while. So drop while is like a skip basically, but it uses a condition rather than a fixed number. Okay, fine. So drop while is okay. Fine. Fine. So from the input side, initial elements, fine. If they satisfy this test, then drop them. Okay, then don't send them in the output. As soon as this test fails, start sending it out. Okay, so only when the test fails will it start considering those elements for the output side. Limit is on the other side. Limit is saying, okay, don't send more than so many elements on the output. So output is restricted to n number of elements. Okay, fine. Whereas we have the other method called take while. Okay, so take while says, okay, you are putting elements on the output, fine, but keep on sending them in the output, okay, till a predicate is, only when the test is passed, those elements will keep on going. But as soon as you come across the first element where the test fails, stop, don't test further. Okay, don't send anything further. So output stops as soon as the test fails. Okay, and so that's a take while method. Okay, so what I have done basically is I have organized these methods into, basically I have categorized these methods. Okay, fine. If you look at these methods, all of these methods can result in reduction of the number of elements in the output side. Fine. They have a possibility of less number of elements going in the output side. Here, each of these methods, you can see filter, distinct, skip, drop while, limit, take while, and they will reduce the elements, possibility of reduction. Fine. Okay, the next set of methods are the ones which keep the same number of elements. In whatever I have received, you will get equivalent one element per whatever I have received there. Okay, fine. Yeah, so this one, first three methods here are just about changing the kind of stream which will be there. So this stream till this point, whatever it may have been, I want the stream to be now becoming a parallel stream. Fine. If it's a parallel stream, okay, the output which is being generated, fine, basically it also requires on the input side the support to be there. The input side, whatever are the elements being coming, I'll be applying some way a split rater, fine. I should be able to split them and do my processing whatever is needed, fine, in parallel way, and the output side, fine, will be able to receive in more of a small chunks rather than one entire a particular sequence. It won't be remaining a sequential thing, but rather parallel chunks can be there. Okay, right. So you can stream was parallel, you can make it sequential also. If it is sequential, you can turn it into a, so these are more of a suggestive thing. It's not always that something which is sequential will can always be turned into a parallel. Not everything can be parallel. It depends on what each of those intermediate operations is trying to do. Okay, there could be some intermediate operations which cannot be parallel. Fine? They cannot be broken. For example, if you want the things to go in a sorted order, oh, then it cannot be parallel. It will have to become sequential from that point. Okay, fine. So parallel, sequential, that's a kind of things. You want to say, okay, this is unordered. So this is more of a suggestive thing that this is unordered. You need to process it accordingly. Okay, fine. Another one is a on close. Fine. You give a runnable. So that means this stream, whenever the stream closes, and any stream will close as soon as the terminal operation finishes. Okay, streams which are in the pipeline, all the streams which are in a pipeline, involved in the pipeline, there were so many stream objects, right? From one stream you call an intermediate operation, you're getting one more stream object. Okay, and they are building the whole pipeline, right? When you put the terminal operation, Okay, the pipeline will execute, and when the pipeline execution is over, okay, all the streams will get closed. You don't have to call the close method. Anyway, close method is available, fine, but you don't have to call it. Fine. Normally it will be. So what you are passing here is, if this stream gets closed, I want to do this operation. Fine. So you can give a runnable, which will get started in a separate thread. Okay. Fine. So if the stream gets closed, I want to do this. I want to do certain things. So this is what we call as a close on close method. So it's a close handler which you are supplying. Okay. Fine. So these are just nothing but some kind of a changes being applied. The number of elements do not change here. Okay, no effect on the number of elements. Even the next few methods which are there also the number of elements will not change. And for example, we have the method called map. Okay, what is map? Okay, I have a stream of account objects. I want to make it into a stream of the names. So it will be a stream of string. Fine. So from each element in the input, element in the input was account, but element in the output is the string, because it's a name which I'm passing on for the next level. So input, output, yes, input was 1, corresponding to the input which I have received, I got a function. If you give this, I can convert into another type. Right. So this is our mapper function, right? Function. Okay, fine. The next method says map to int. So in this case, it is still becoming a stream, but it's a stream of primitive type. So it's also an intermediate operation. Fine. It's a given element from the input side, which will be of type t. Okay, I need a function which can give me an int value. Right? So if you are able to give an int value, yes, it will become an int stream now, because now the elements in this pipeline which will flow out from here will be type int. Okay, same way, map to long, map to double. Okay, fine. There's also a method called peak. In case of peak, fine, we use the method, we use a consumer. Fine. In peak, we use a consumer. Okay, fine. Consumer is, yes, this okay, peak method we normally use for debugging purpose. Fine. We normally do it like, okay, what is the action to be taken? Whatever element is coming in the input, I do something, but the same element will just pass on to the next stream, next level. Okay, but I can be taking some action based on the object received. So normally we just say, okay, let me print this element. Okay, so your action, the consumer can be about printing the element when using a peak method. Okay, and sorted, that means, yes, the output, the elements will be going in a sequential manner. It will become a sequential stream, and the elements will be coming in an order according to the comparator specified. So you need to pass a comparator in this, so that it decides what is the ordering to be done. And so these are some intermediate operations, fine, which are resulting in the same number of elements. Then we have another set of intermediate operations where the number of elements, there's a possibility of increasing the number of elements. Of course, it may even result in reduction, but or maybe keeping the same thing, but normally this would result in increasing the number of elements. Okay, a good possibility of increase in the number of elements, right? So for example, okay, we have this first method called flat map. Okay, so when we say flat map, right, what we need to do is we need to pass a function which for each element again gives out a stream. Right? You give me one element and I'll give you a stream. So you will now have a stream of another type. See, for example, okay, if I consider our whatever we have done in our exercise so far, that account class, see, right? In the bank class, we are managing all the account objects, right? And in the account class, if you see, we are managing the transaction objects, right? In the bank, we can have a method to give us a stream of account, right? Now, given a stream of account, okay, for each element of the account, I can have a stream of transaction. Okay, so if you are having a stream of account, my input was account, I'll say, okay, in my output, I'm giving you all the transaction across all the accounts which I'm having. Okay, fine. You are not interested in processing in each individual account, but rather you want to find some statistics which are related to the transaction across all the account objects. Someone wants to find out which is the transaction having the highest amount, irrespective of which account it belongs to. But my input was, okay, I have this bank object, fine. In the bank, I start with the I'll start with the account stream. From the map, I can fetch the account stream. From the account stream, I would like to convert it into a stream of transaction so that I can work on the transaction part. Okay, so if you are interested in working on transaction, yes, you can use the flat map method. Okay, fine. We have the flat map to int, we have the flat map to long, and we have the flat map to double. Fine. Input side is some type t, output side is an int string, long string or double string. And so flat map, for one element, I'm able to generate a string and I'll be able to use it. Okay, fine. There are some more methods which were available from Java 16. Okay, and so these are available from Java 16. This is a method called map multi. This is also generating for one element, generate multiple elements. Okay, see, these were not originally there in Java 8, and therefore they would be there as default. Okay, fine. So given a stream of t, your elements are of type t. Okay, fine. You are returning a stream of r, some type r. What we require in this map multi is a by consumer. By consumer means to input. Fine, doesn't return a value. But look at the by consumer. One is the element from the stream. T is that element from the stream. For each element of a stream, I will have to write a method. Okay, fine. I'll have to write the implementation of this by consumer. What it does is it gets two inputs. The first input is the element. The second input is a consumer object. So it takes one element. Fine. It decides, okay, while processing this one element, can I generate multiple values or whatever values I can generate of type R? I will call the accept method on that consumer of R. Okay, it calls the accept method on the consumer of R. Consumer has method called accept. Right? So for each element for which he pushes, so in the consumer you are pushing elements by calling the accept method on the consumer. Okay, fine. So if you do this, yes, it will then be all those things for which you call the accept method, you are passing it, yes, they will be coming, they will be the output side of this string. So input side is t, but output side is decided by what are the elements you gave to that consumer. Okay, when you write the by consumer. Okay, and so this is the map multi method. So this is where we have the intermediate. This is so like this. It is meant for int, long, and double also. Yeah. Okay. So in stream, yes, I'll skip this. In stream, almost similar things. Map multi thing here also. Okay, and then we have the terminal operations. So terminal operations, for example, from the previous stream, the output available from the previous stream or whatever that source is, right? Okay, on that I'm saying I'm passing a predicate and checking if every element in this is passing the predicate test or not. If it passes the test, yeah, this would return true. Fine. So we can do all match. If any one of the elements is matching this predicate, that I can ask for true or false, or I can say, okay, there's none of them which matches this. So, fine. So all match, any match, none match, these are nothing but the terminal operations. Actually, we'll have to do some example to understand this better. Okay. Okay, we have the count and other things, right? So yeah, we have all the, I think, let's come back to the notes and let's try using some of the methods there, so that you get an idea of how it is used. Okay, fine. Okay, one thing is, I'll put some enhancements which need to be done in the account class. Account class as well as the bank class. Okay, in the bank class, let's do it in the bank class. Stream. We have to add a method to return a stream of account. Okay, and same way in the account class, add a method to return a stream of transaction. Okay, so we can have a method called get account stream in the bank class and get transaction stream in the account class. And first do that change here. Okay, in the account class. I'll add in the beginning. Okay, before we start the class transaction, let me put it here. Public method to return a stream of transaction. Okay, get transaction stream. Fine. And this is simple, right? Return this dot passbook. Right? Passbook is a list which is a collection dot string. Right? Okay, so we are able to return a string. Right? Passbook has all the it's a collection, right? Passbook is a collection of transactions, and therefore we have this method called stream, right, which returns a stream of all the transactions. Okay, account is one, and we have the bank. In the bank, again, let's add a method in the beginning. Okay, I'll add here. Okay. So we want to have a public method to return a stream of account. Get account stream. We have the account map dot. If I look at the values, okay, that's all the account objects and dot stream. Okay. So find simple things, right? How to create a stream initially. So this is how you get a stream. Okay. And I'll put it in the notes, right? So now if this is how we have got the methods, right? So someone says, okay, I want to get the account which has the yeah, which has the highest balance, right? Or you want the summary statistics. Okay, anyway, you can have something like this. Okay. Just using the intermediate operator, okay, all match, any match, none match. Okay, so you want to know if there is some account which has a negative balance, account with a negative balance, right? So you can test like this. This could be done in the test bank class, where you can say, okay, in the main method, since you have the bank object, right? Bank was created. Okay, so this we have done. Bank creation is done in the test bank. Right? You can say Boolean. Okay. Okay, all have positive balance, right? Okay. And this will be bank dot get account stream dot, and you can just say all match. Okay. Given an account dot get balance is greater than 0. Okay, that's what I was interested in. Okay, or you want you would like to do a similar thing but only for the current account objects. Yeah, if I want to do it only for a current account objects, yeah, how do I do it for only the current account objects? Apply a filter. Okay, what is your filter? So see, what normally we follow is that right, every dot we take it to the next line. Okay, and that's a convention. Yeah. Okay, so what's the filter you would like to apply? Given an account, so only if it's a current account it goes further. Filter them this way. And here is instead of this you could say, okay, right? So you're only interested in knowing whether all good is for current account is if all of them have account balance greater than the minimum balance. Clear? See, this is the initial source creation part. Okay, bank dot get account stream, and then these are the intermediate operations you are doing on it. One is a filter, so that's only one intermediate operation, and this is a terminal operation, all match. Right? Because all match returns a boolean, it's not returning a string. Filter returns a string, so it's an intermediate operation. Then got the idea how stream is to be used? Okay. And so with this, yeah, this is how the terminal operations will work basically. And before terminal, yes, you can do all those intermediate operations. And we have seen that intermediate operations using a terminal operation. So here is, okay, these are more statistical. So you can use count, min, max. So when you say min or max, you can see what it is returning. What's the return type for min? It says optional. Because if it's an empty stream, then optional, right? I don't have a min, I don't have a max. Okay. For the primitive like in stream, long stream, double stream, we do have method like sum and average as a terminal operation. Sum and average, those are the methods available. Okay. Fine. These are simple methods. You can just say find first or find any. See, find first is if it's ordered. If it's an unordered stream, you'll just say find any. In same way, for each, this is a common thing, right? It's very commonly used for each, and you have to pass a consumer. And for each ordered means, yes, for each ordered, yeah. If it's a sequential stream, right, then you'll have the for each ordered, and you may use that method. Okay. Converting into an array, all the elements which are there in the output side of the previous stream, okay, I want them to be converted to an array, or I want them to be converted into an array of a specific type, because the previous one will always return object array, but I want to create object of a type A. Okay, so this is the two array method. Here it says int function of array of type A. Okay, fine. So here you have that example of constructor reference, right? I was mentioning constructor reference yesterday. So that could be used here. It's an array creator. Okay, from Java 16, from a stream directly you can convert into a list. Elements in a stream, okay, whatever they are, let them be converted into a list and give it to me. Okay, fine. And then the next thing will be about some more advanced terminal operations, which are the methods called reduce and collect, which I think we'll be looking at tomorrow. Yeah. Okay. This just repeating the same things for the int stream. Similar methods for the int stream. The terminal operations for int stream, they are mentioned here. Right? Yeah. So yeah. So that's for the day. Yeah. So. So any questions? Yeah. You may like to try out some of the to-dos, right? Go through the to-dos, try out some of the to-dos. Okay. Comparator thing, there are to-dos for that comparator thing, how to sort. So try those sorting things, and also see if you can try some of the things related to the streams. Okay. But the most interesting methods are is the collect method, basically, right? So reduce and collect, very interesting methods, right? And you'll find there initially they may look difficult, but they are not actually difficult, quite simple. You actually have been using similar things in your code most of the time, but it's like the library will do it for you. You need to give the appropriate functions. See, here you have been working with functions, isn't it? You use lambda expression, so much of it, right? Filter, pass a function, which is a predicate function. Fine, all match, pass another predicate. Fine, another example of a default, this is from, so you have seen collection earlier, right? If I have a collection of E, one of the default methods, okay, what are the default methods? Fine, I think a few default methods I had listed. Okay, for example, one of the default methods was for each, recollect, right? So public default, and the method name is for each, parameter is a consumer of E, that's an action to be taken. And this is something very commonly used, right? But we even have another one, default method, remove if. Parameter is a predicate of, okay. So only if it passes the test, it will, if it passes this test, it will get removed from the collection. And for example, someone says, okay, I have a collection of accounts, right? Okay, if there is a collection of account, okay, CA equals, right? You could do like this, okay. Maybe there are some accounts which have got negative balance, CA dot remove if. Okay, and here you can just say, given an account dot get balance less than 0. Yeah. Fine. So this is a simple thing. You don't have to write any loop or anything. You're giving the test to the collection that, okay, just do this, check all the elements. If you find any negative, remove them. CA collection of, find collection of account dot remove if, and here's the test. Okay. So see, remove if, that's a method of collection. Okay. Fine. The idea here is you start using functions, you start using those lambda expressions. You're fine, you need to understand them properly, and if you start using them, your code will be such a short code, you will be achieving a lot of things. Just with small piece of code, you can do a lot of things. And tomorrow when we look at that advanced operations, right, the collect method, reduce and collect method, yeah, they are fine. That's the agenda for tomorrow, and that's a most interesting part. Okay, how they work, we'll see how they actually work. Okay, how the reduce is working, how the collect method is working. Fine. Yeah. So any questions, yeah, about the streams or any other thing which we have seen earlier? Yeah. Any questions? Yeah. Anyone has questions?